Assalamualaikum and good day to everyone. I am Sayang Eliana Amira binti Helmi with metric number A20AC0143. This presentation is my final year project 1 entitled Early Detection of Alzheimer's Disease using SNN on Brain MRI. This presentation will cover the project problem background, aim, objectives and scopes, literature review, research methodology, list of system requirements, research design and implementation, summary of PSM1 initial findings, and the discussion on PSM2 execution plan. Problem background. Alzheimer's disease is a neurodegenerative disorder that leading to cognitive decline and functional impairment. Early detection and intervention are vital in improving patients' prognosis, as current treatments are most effective in the early stages of the disease when using medication and modern therapy. For problem statement of the study, limitations in detecting AD in the early stages using machine learning is limited because of the low image quality, issues of pre-segmentation and pre-processing steps, the absence of a database with sufficient number of subjects, and the complexity of medical images, which I believe that this may lead to inconsistent and redundant of the classification and detection of the disease. Research aim of the study is to develop a detection of Alzheimer's disease model with a high accuracy by comparing the performance of adaptive learning rate along with the different activation functions on CNN model. The research objectives are to compare the performance of adaptive learning rate methods, Adam and RMSProp on CNN's model for the early detection of AD from brain MRI scans, and to compare the efficacy of different activation functions between ReLU, LU, and SoftMax on the performance of CNN's model for early detection of AD from brain MRI scans. The scope of the study focuses on building on algorithm to classify two classes of brain MRI, which are the normal control and AD. The dataset used is cited from OASIS, which comprises 150 subjects ranging in age from 60 to 96. The dataset is available on the OASIS website. The study compares the performance of adaptive learning rate methods, Adam and RMSProp, on a CNN model. It will also evaluate the impact of different activation functions between ReLU, LU, and SoftMax functions on the performance. The programming language that will be used is Python. Next, literature review has been conducted for the study. Research trends on the detection of Alzheimer's disease. Early detection of AD at its prodromal stage is crucial because of the reliance of machine learning methods on traditional way feature extraction can be a long drawn-out and subjective process that requires technical experience and repetitive attempts, mentioned by Heledi et al. In 2022. They also mentioned that alternate procedures such as CNNs have arisen with the ability to outperform traditional methods in terms of speed and efficacy. Brain MRI. In recent years, it has become an important tool to detect neurodegenerative disease such as AD. Manually identifying cases with poor diagnostic quality is tiresome for professionals, especially MRI scans that have low signal-to-noise ratios, stated by Oxus in 2021. He also mentioned that CNNs have proved crucial for determining image quality with high accuracy for lossy image compression. For feature extraction, there are advantages and disadvantages working on extraction, as mentioned by Dingra and Bansal in 2020. The advantage is a feature extraction reduces the dimensionality of the data, making it easier to process and analyze. However, feature extraction can be time-consuming and computationally expensive process, especially when dealing with a large datasets. For CNN's architecture, CNNs with multi-layers such as pooling, softmax, regression, and completely interconnected layers is used to detect the disease. For activation functions, it is to utilize in neural networks to determine if a neuron should be activated or not, by calculating the weighted sum of inputs and biases, stated by Praniselvam in 2021. Adaptive learning rate can be utilized as an improvement to traditional gradient descent algorithms, stated by Kuhn in 2017. Shown is the summary of recent researches done, which all of them were obtaining the dataset from IdenTi database. They are using different methods, which are both machine learning and deep learning methods. As for the measurement, accuracy is the common performance measurement that is used, resulting high accuracy for detection of AD. Moving on is the research framework. There are 4 phases implemented in this research framework. Phase 1 is the collection of studies, which resource collection is done, study and identify the problem background, problem statement and scopes, reviewing recent researches, and planning the workflow of this research. In phase 2, data preparation and preprocessing is done. The dataset chosen is OASIS-2 longitudinal MRI data in non-demented and demented older adults from OASIS database. Exploratory data analysis, data normalization, and feature selection are done in this phase. Phase 3 is the model development, where the development of the proposed and ENS models for AD detection will take place. The last phase is for testing and evaluation. In this phase, the research will focus on evaluating and analyzing the performance of model in terms of accuracy, sensitivity, and specificity. The next one is the list of system requirements. The first one is operating system that will be used is Windows 11. Number 2 is Python IDE, Microsoft Visual Studio Code and Python libraries will be used, and working files are saved in Jupyter Notebook format, which is IPYNB. The RAM that will be used is 8 GB size RAM, and ROM is the 524 GB of disk memory, NVIDIA GeForce GTX 1650. Data preprocessing. The steps involved in data preprocessing are checking missing values, imputation, and data normalization. Before the preprocessing, number of rows, which are the samples, are 373, while the number of columns, which are the features, are 15. After the preprocessing, the number of rows are lessened to 142, while the number of columns are lessened to 8. Shown are the tables of the dataset before and after preprocessing step. For feature selection, Boruta algorithm will be used. The steps involve concatenate shadow features to the original dataset. Next, train the new dataset using the random forest classifier. And then check feature importance for the highest rated shadow features. And then all original features that are more important than the most important shadow features are the ones that will be used. Step 3 and Step 4 will be repeated for some iterations and keep track of the features that appear or important in every iteration. The last step is binomial distribution will be used to finalize which feature provide enough confidence to be kept in the final list. Next is data splitting. Data splitting involves dividing a dataset into training and test sets for the deep learning. Training set is used to train the models, while the test sets evaluates model performance on seen data. The dataset is split into X-train, Y-train, X-test, and Y-test subsets before feature selection techniques are applied. So with the raw dataset, 30% of the dataset will be used for testing and another 70% will be used for training. Moving on, there are three performance measurements that will be used. The first one is accuracy. It is the amount of data that is predicted correctly out of the total data in the testing set. Number two is sensitivity, which is used to measure the capability of the model in predicting true positive from prediction result. And the third one is specificity, which is used as the measurement for estimating the model's proficiency to predict the true negative from the prediction of the negative result. Shown is the research design and implementation flowchart. The first one is we use OASIS-2 dataset, longitudinal MRI data in non-demented and demented older adults. And then the dataset will be go through on data cleaning, data preprocessing, feature selection, and performance measurement will be evaluated. In the design and implementation, feature selection use is a Boruta algorithm. It is used as feature selection method, which is able to select optimal features carrying usable information for model's prediction. It is also act as interface medium on a random forest classifier, which utilize the importance measure generated by the original platform. Only features that statistically more important than these synthetic features are retained as they contribute more to model performance. For activation function, it is to add an nonlinearity to neural network, typically follows convolutional layers to create a feature map corresponding to each filter. Activation function also modify the input data and generate an output for the neural network, which contains data parameters. For adaptive learning rate, it is to optimize the learning process by dynamically adjusting the learning rate based on the progress of the training. And it also allows the model to make large updates when the gradients are steep and small updates when the gradients are shallow. The first activation function will be used is rectify linear unit, which is ReLU. ReLU possesses a derivative function, enabling efficient backpropagation and computational effectiveness. However, the key characteristic of the ReLU function is that it selectively activates neurons. Neurons are deactivated only when the output of the linear transformation is below zero. Okay, as shown in the figure, this shown is half rectified from the bottom with a value of 0 for RZ when Z is less than 0 and equal to Z when Z is greater or equal to 0 with Z ranging from 0 to infinity. The next one is exponential linear unit or ELU. ELU adjusts the negative slope segment of the function by utilizing logarithmic curves to represent the negative values. It serves as a robust alternative to ReLU as it gradually smoothens. As shown in the figure, ELU is similar to ReLU as both functions assume the identity function form for non-negative inputs. But as mentioned, it adjusts the negative slope segment, which compared to ReLU. Another activation function used is SoftMax functions. It is often utilized to address multiple classes and was previously prevalent in the output layer of image classification tasks. This function normalizes the output for each class between 0 and 1 and divides them by the sum of the outputs. The figure shows the high value will have high probability. Ideally, the SoftMax function is employed in the output layer of the classifier to determine the probabilities of each input classes. The next one is adaptive learning rate. The first optimizer that will be used is root mean square propagation, or RMSProp. It is an extension of gradient descent that uses a decaying average of partial gradients in the adaptation of step size for each parameter. It is also designed to accelerate the optimization process, as such decrease the number of function evaluations required to reach the optima. The next one is adaptive moment estimation, which is Adam optimizer. Adam optimization calculates exponential moving averages of both gradients and their squares. These averages are subsequently utilized to determine the update for each parameter during the training process. It allows for adaptive learning rate adjustments, resulting in improved optimization performance. The justification of chosen activation function would be the ReLU is thought to be the most highly used in recent researches in detecting and predicting Alzheimer's disease, giving its high performance in accuracy. Despite of the fact, ReLU and SoftMax are also chosen in this research to compare and evaluate the result of each activation function performance. For adaptive learning rate, Adam optimizer is commonly used in recent researches, resulting in high accuracy with 90% and above. Considering the factors such as convergence speed, optimization stability, and ability to find the optimal solution, RMSProp is chosen to be compared. Next is summary of initial PSM1 finding. Giving the objective to compare the impact of different activation functions between ReLU, LU, and SoftMax on the performance, the expected outcome would be to obtain high accuracy of the detection from ReLU activation function, as it showed a good performance in previous studies. For the next objective, which is to compare the performance of adaptive learning rate methods, RMSProp and Adam, the expected outcome would be Adam optimizer is expected to give high accuracy compared to RMSProp. The last part of the presentation will be the discussion on PSM2 execution plan. First and foremost, further optimizing the algorithm of activation function and adaptive learning rate, and compare the result from each algorithm to get the best performance. And then the performance of the model will be evaluated according to its score of accuracy, specificity, and sensitivity. The detection of Alzheimer's disease will be done with the highest accuracy obtained. That is all from me for this presentation. Thank you.